me. I'll start talking whilst Alexi's setting up the slide, because I know there's not a lot of time and we'd like to get back on time. But my name's Andy Davidson. I'm with Hurrican Eletctric, but also two internet exchange points in the UK, Lonap and IX Leeds. I'm looking at the RPKI work from an operational point of view. So the question that I plan to answer with this presentation is, if you're interested in all of the topics that Dave Freeman has just presented, this is how you might like to build a lab and play with them. The talk is divided into three sections: a quick overview with a couple more use cases that build upon some of the topics Dave presented, and then a presentation on how you can build your own CA using the services of the RPKI CC. They operate a user-definable certificate authority. And then if you'd like to actually validate routes, how you can actually build a lab in your own company and start looking at real prefixes that have been origin validated. Here we go. That looks good. Okay.
This so like I get them online.
Yes, of course. So, IP resource certification. I just want to attribute some of the work of Randy Bush, which I say on the side that I've acknowledged these concepts. That's really just means I've stolen the concepts. And also the work of Alexander Band at the RPKI CC, who's been delivering this project to build the RPKI certificate authority, the member certificate authority system, and has given me some help with other online resources that I've put together. So, the premise of RPKI is that everybody in the room, we all love routing, but we're not very good at it, because we've got to a point many years after building the first routing systems where we can still cause accidental outages with enormous customer impact. The YouTube example is one that Dave cited, but there are simple examples that happen all the time. For example, when some networks turn up a transit customer, they often don't filter their transit customers. The transit customer tries sending them a full table, and that can cause outages, performance problems while you're debugging and turning that off again. And could also mean that you then start offering a full table to your peers at internet exchange points, meaning you trip max prefix with your peers and have to go around begging for sessions again. So there's lots of accidental impacts to routing, but there are also deliberate attacks on the routing system. We've seen, we've heard about the DEFCON net example in the last presentation, but it's very common now to see darknets, which are IP ranges which are not intended to be used on the internet or not yet assigned to a customer, popping up on the internet and being used to distribute spam and abuse traffic, which means that when those addresses become assigned, or the rightful owner starts using them as they intended, they find that the addresses are already in blacklists and not so useful for their hosting customers or whatever. Oh, and another example with routing security that was discovered a couple of years ago, when ICANN started distributing their LRoot systems around the world, they found that there were a load of LRoot clones that were set up for possibly good, possibly bad use, and getting all those turned off took a long time as well. So, yes, we love routing, but we're really bad at it. Now, as Dave cited, can we mend this with IRR? But yes, that is if our customers actually publish the data in the IRR, then we might be able to use it. But then which IRR? I went to IRR.net to have a look at how many databases there were, and there were around 20 more than I even thought there were. And that's as someone who uses IRR every day. So even if our customers actually used an IRR database, which ones do we build our prefixes against? So the sort of one possible solution to this is the idea of running with certificates. And here's a fake certificate that I made that says just something along the lines of Hurrican Eletctric, where we are the rightful users of the AS number 6939. But crucially, this system is just a way of representing who owns or who operates an internet resource, what the resource is, how long they're entitled to use it according to this certificate, and who said that this was fine. Using the certificate, once you have a certificate for a resource, you can sign a root origin authorization. So you build a certificate authority, you make an end user entity object, which is the certificate authority's signed version of the resource, and then you attach the resource to an origin to say that this origin is entitled to originate this resource. This is the express permission, and this gives us as internet operators some data that we can do origin validation with. So really there's a 3-step process if you want to actually get around and play with this as an operator today. First of all, you have to build a certificate authority, sign your end user entity certificates, and publish an ROA. Well, the Ripen CC have very kindly been working on a certification system in the LIR portal, which I'll draw some screenshots from now, and I'll show you just how easy it is to build. If you want to outsource the job of running the certificate authority from you to the Ripen CC, the process of building your certificate authority is to log into the IR portal, click on certification, and click on I accept, and then you're done. The process of building a certificate authority is very simple. Once you've done that, you can actually then go to the My Certified Resources screen, look at the resources that, once you've made your certificate authority, Ripe automatically certify your resources as well. So you're able to build ROAs against all of your resources automatically. You don't need to import them into any other tool. You can basically start to build ROAs for your certified resources just by dragging and dropping them into an ROA builder, typing the AS number that's allowed to originate them, and optionally you can define some dates for when the certificate will be valid from and to as well. And that's all it is. You click a button to create the CA and you drag and drop some objects. Once you've done that, you can view the ROA to confirm that it's been made as you expect, and then you're done. The job of publishing the RPKI data through the NCC's tools is complete. Now other operators who are using the RPKI system can validate that the rightful user of these resources is originating them in the routing table. And you can actually browse, if you go to certification.ripe.net, inside that website, you can actually have a look at all of the ROAs that have been published under the Ripen CC's tools. This actual feature is about 2 weeks old only. Before you had to build the rsync interface yourself and grab all the data, but now you can actually browse through that data on certification.ripe.net and have a browse at what other people are doing. In terms of activity, there are about 400 signed ROAs right now in the Ripe system. Ripe have got more ROAs than any other regional internet registry who's working on this. You can see on this graph that in Europe we've been particularly keen on working on this, more so than operators in the other regions. So once you've created an ROA for your for your resources, how do you verify others? If you want to build policy against the ROAs that have been signed already, what you need to do is build an ROA cache of the sort that Dave described in a previous demonstration. You build a cache that can collect ROAs from other publishing certificate authorities, and your router talks to the cache and asks it when it receives an update for a prefix, is this being originated by the people who are entitled to do so? And you influence the routing table via policy you configure on the router. The answer from the cache in the middle can be yes, this prefix is originated in a valid way. There's a matching ROA and AS number. It can be invalid. There is an actual ROA, but the update we've received doesn't match the policy that's described. Or it can be not found. There can be no ROA, and we can build different policies based on these 3 individual scenarios.
Question.
Of course.
What if some prefix is announced under 2 different autonomous system numbers? What would be the response?
Build 2 ROAs.
Yeah, but what would be the response? Would it be valid, invalid?
It will be valid. If you received an update from an AS and there's a matching ROA, and then it will be valid. So you can just build. In the same way that if you originate a prefix from two different ASMs today, you can publish two root or route objects in the right database, and that is a valid scenario. It's the same. So here's some example configuration that you can use if you've got hold of. You can get hold of the IOS that you can run in. I think 7,200 images that have got the RPKI features turned on that you can run. You'll see that the config looks by and large exactly how you would expect it to if you're running BGP, but there's this additional line in yellow which tells the router where to go and where your proxy is that can give these valid, not valid, or not found answers. And also, when you can build route maps against your peers and actually say, which say if the route is invalid, do this. If the route is valid, do this. And if the route is not found, do this. So you build a policy which matches the three conditions that your cache might require. If you're using iOS XR, there's also another image. You can use route policies in order to shape your routing policy using iOS XR rather than route maps, and you can do exactly the same. You can match. Another example, you can match what to do again if it's valid, not valid, or not found. One day it may be safe, although this is possibly some point in the future, it may be safe to say match if there's an invalidly originated prefix that you receive an update for, you can simply drop that prefix. And if you want to do that, then that's the fragment that you run on iOS in order to make that happen. And also you can, using the policy, you might say if I receive a prefix from a peer and the prefix is not found, I'll allow it, but drop it right down in terms of priority, so that if I receive a valid prefix later on, the route that I've imported is going to lose out. So that's an example of a stricter policy that we may be able to one day use with RPKI. If you only want to import prefixes that have been signed, so for example in your laboratory system, if you want to just build a routing table with signed objects only, these are the route maps how you do it: match RPKI valid, import the route, but everything else just drop it. That may well be safe one day as well. And in your lab, if you want to build this development environment and see what happens, if you go to rpki.net, you can download one of the pieces of software that allow you to that can sit as this cache that gives the answers. There's actually a Subversion repository that's on the slide right now, which is where you grab the code from. The RPNCC have another validator that's open source, but I'm not going to promote that one because it's written in that nasty Java language. The RPKI stuff we have today is not a magic bullet. Path validation is still missing from what we can do today with RPKI. So these man-in-the-middle attacks that are described where you receive traffic for a prefix and then hand it off to its rightful owner after inspecting it or filtering it. The routing system, even if we import all of these features today, will still be vulnerable to man-in-the-middle attacks. The code that's out there is very early days. There's lots of testing work to be done, and there's a big discussion with relation to policy about trust, which was cited in the last presentation. But who do we really trust? And if RPKI is tantamount to an off switch for a prefix, then how do we make sure that this can't be used for political ends rather than legal?
Question.
Sure.
Did you already cover the case where somebody, a malicious attacker, announces more specific?
And more specific with this would still be important because the most specific route always matches. But if the more specific route, if you're dropping prefixes, if you're running one of these route maps that say if the ROA is actually invalid, if I receive a prefix that's a more specific but it's invalidly originated, the wrong AS number originates it, drop it rather than just drop the local pref, then that will bin the prefix. But if you just drop the local pref, which is some of the examples that are being used today, that won't drop the prefix. project.
There's also been some discussion about changing the way the longest path prefix matching algorithm works with regards to this, because you might want to consider something but depreference it, right? Unless there's, I pick an aggregate, unless the aggregate goes away, then follow the more specific.
Yes.
Which is weird to think about.
Which is very weird to think about. I wouldn't like to be debugging that. Hopefully, if that work continues, it will happen long after I retire, because that's the last thing I'd like to debug. But right now, longest prefix wins is still the paradigm that we use. So
but the thing is that if somebody, let's say that I have a /23 and I has a valid RPKI signature for it and so on, and then somebody tries to hijack half of it, the system will match that route against the row for my /23 and not for the magic 24.
Well, you can make your rower, you can say, this rower is for my /23 and more specifics of that. So you can build a rower that allows you to that allows all more specifics right the way down to a single host, I believe. So that more specific announcement will still match the legal rower, and the rower would advertise as the wrong origin is originating it. So anybody who's doing match RPKI valid drop would not say the best. Would not say the more specific yet. So, but again, these are early days. I think people will run more and more lab environments with more and more complex routing policy over the next few years, I'm sure, and we'll match these accidental attacks that are happening now, and we'll be able to compare what the policy has caused to happen with what happened on the routing table at large, and understand if the work we're doing is worthwhile. So that's the operational aspects. Are there any further questions or comments about RPKI in general?
I have a question. How do you see the future in an RPKI and perhaps BGP set validating future, where a transit customer turns up and says, "Yes, I'd like some transit, please." What sort of additional information are you going to need to capture? What sort of things are you going to need to tell them?
Well, if you're a responsible transit provider and you're checking in the IRR database for the prefixes that they should be able to announce to you, at least as part of your due diligence, even if you don't build automatic filters, if you have a look at least what they tell you they're meant to be advertising at the time they sign the contract and check that it's what they're asking you to transit. And that's the thing, the work is no different to them. They've got to publish their prefixes somewhere, and actually, if they use in Europe the NCC's tools, all they have to do is drag and drop resources and mention their AS number inside the IR portal, which is easier than trying to describe the RPSL specification to all of your transit customers. Because if you try to do that, those tend to be quite long conversations that sometimes just result in, look, just give me your maintainer password and I'll sort it out.
Exactly. I mean, sometimes when you say to customers, you need to make sure that your root objects are published properly and that I can do the filters, that I can build my filters. There are a number of cases outside the right region where that doesn't happen, or where it's said to the customer, you need to do this. The customer says, I don't understand. The salesperson says, we need to get this up and running. Somebody puts a manual hack in. It's going to become harder to do here because you can't generate the routers for them. So you're going to have to. I guess it's a similar concept in that you'd have to put in overrides when you accept them, but then your peers are going to be able to do those overrides. So.
But if they're running BGP, if your customer is running BGP, then they've got someone in the team who's actually gone and bothered to learn something about the protocol anyway. So they've learned step 1, step 2, step 3. If they now have to learn step 4 as well, then that's just going to have to be the way it is. If you have a customer that's talking BGP, they understand to a point. They need, if we change the BGP protocol or we extend the BGP protocol in order to have a secure routing element, then that's just a change to the protocol, and they're going to have to learn that. In terms of, but the commercials around these this go much further than when I turn up a transit customer. Do they have enough clues to make growers? There'll be questions along the lines of if they're running if these customers are running BGP, then it's likely that they might want to start checking themselves as well. So as a responsible upstream, you have an option to maybe sell them access to your rower cache or rower validation, or maybe a group of operators might come together and say, hey, we'd like the exchange point to offer this service. Just throwing it out there, and now that's likely not to be something you're asking for at the beginning, but it might be a service that an exchange point can operate, maybe as a way to grow additional funds for the exchange as well. They could host the validation engine. But this needs a lot of testing. The commercial models and the technical process still need a lot of testing. So it's possibly quite early to make some of these assumptions yet.
Sure. Thank you.
What do you think what do you think are the biggest incentives and disincentives for a big backbone operator to run RPKI?
Well, they are the incentives and disincentives are the same for all of us. Big backbone operators will have many hundreds or many thousands of customer relationships, and the process of maybe educating or working with all customers will be a long process if you have many customers. But the benefits are, for all of us, a more stable routing table and less chance of our own prefixes being hijacked. A large backbone operator may say, well, it's very convenient this idea that we have to start certifying all the resources and checking all customers are certified as well, and then maybe checking all our peers are certified as well. This is an awful lot of work for us, but the work involved with a large backbone operator having the prefix that their website sits in is difficult and impacting as well. And if this work that we're doing makes that harder, I think it will save effort in the long run. And that's the incentive. Otherwise, there's not a lot of point in doing the work. So that in my view, the incentive is a more stable routing table, and that benefits everybody. But the disincentive, the disincentive is that the burden sits with the larger operators more so the smaller operators.
What about threats when there are some sort of bugs like or not just bugs, but somebody forgets to renew a CA?
Yes. But what happens if someone forgets to renew a SSL certificate for their e-commerce portal? What happens if you're running DNSSEC? What happens if you forget to do your rollover time? What happens if you forget to buy milk for the office kitchen? That's also an operational emergency. If your engineers can't get coffee, they're not going to do any work. There are all these things you can forget to do, and all of them are bad. But if you write proper operational checks for your monitoring system, you should be able to see, hey, the certificate's running out, so I need to build a new certificate. And if you check for that once a day, even if you just run Nagios and write a check that runs every day, is the certificate valid for more than a month? That should catch you. And if you monitor your customers as well, it gives you a nice opportunity to go and talk to your customers every year about something that's going to help them and add value. So everywhere there's work to be done, there are opportunities for adding value as well, and that's just one of them.
I think another potential benefit for ISPs is potentially, if you trust the database and the signing authority, then that could certainly replace really big, long filter prefix list in your routers. You just trust the database.
Yes.
And if your customer is registered, you trust what he's announcing.
Yes. Yeah, these big, long manual lists. I think there may be a talk about root servers later when we talk, and the root servers that I operate at LONAP certainly do prefix filter our customers, and in many of the cases we have many hundreds or many thousands of lines of policy configured, and it would be nice if we could replace that with something that updated in real time and just queried, is this okay, yes or no? That would be nice actually. Again, there are opportunities, but there's a lot of work to do. Are there any other questions? Well, thank you very much, everybody. Thank you.